Good morning, everyone. Myself, Dr. Sakti Prasad, and now this lecture, Correlation Coefficient in Statistics Part 2. In these lectures, we have covered condition of correlation coefficient and description of the strength of relationship between the two variables based on the correlation coefficient, and then for solve example we have discussed based on the ungrouped data, joint probability mass function, and joint probability densities functions. So now we start for the conditions of correlation coefficient rho xy. Now the first condition is that rho xy correlation coefficient always lies between -1 to 1. And now the direction is same, that's why we can write always rho xy is equal to always rho y of x, both are same. Now the third one is that suppose the values of correlation coefficient between xy is equal to 0, means that there is there is no linear linear relationship between two variables between two variables. Now fourth one is suppose we getting the values of correlation coefficient between xy is equal to +1, means that it gives perfect perfect positive correlation perfect positive correlation. Now the fifth is suppose rho xy is coming -1, means that it gives perfect perfect negative correlation perfect negative correlations. Now these are the conditions for the correlation coefficients. Now we move for the description. The next is description description of the strength relationship relationship between two variables relationship between two variables based on rho xy correlations coefficients. So we know that the here is the correlation coefficient lies between -1 to 1. Here we have take minus 0.8, here is 0.5, now here 0, here is 0.5, and here is 0.8. And suppose this is the represent the correlation coefficient between x and y. But now the correlation coefficient lies between this and this, minus minus half to plus half. It gives the weak relations between two variables. It provides the weak relations. And now after that, the correlations coefficient lies between -1 to minus half. That is provide the a strong moderate. And now the coefficient of correlations lies between half to 1. that is its provide means that the moderate as strong. This is the descriptions of the relationship, and this is the way to describe the strength of the relationship between the variables based on the values of correlation coefficients. So now we go for the example. Now one example is that one example. First we consider the first example. Calculate correlation coefficient. Calculate correlation coefficient for the data given below. For the data given below, here x and y is given, means 1 6 2 4 3 3 4 5 5 4 6 2. Now these are the only for here frequencies not given, it is based on the ungrouped data. So now we find the correlations coefficient. First we targeted, first we write, we know that the formula correlations coefficients between x and y is equal to covariance of x comma y, x of y, and here we write the sigma x and sigma y, sigma x and sigma y. Now we need to find the first covariance. Here we write the formula equation number 1, and now the covariance xy is equal to, we write the expectation in expectation form, expectation of xy into expectation of y, expectation of x into expectation of y, and now this is, and again we write the sigma x square is the variance, and then we write the expectation of x square minus expectation of x whole square. This is the formula for the sigma x square, but we need to the sigma x is equal to, this is the standard deviation. We write here expectation x whole square minus expectation x whole square. This is the sigma x, and after that we write the sigma y square. Similarly we write here expectation of y square minus expectation of y whole square, and here we write sigma y is equal to under root, we write here expectation of, here we write expectation of y square minus expectation of y whole square. Now here we targeted to find the values of these values after substituting. This is the covariance term using 1 2 3 and here is 4, and need to find the values of expectation. Here you need to find the values of expectation of xy, expectation of x, expectation of y, expectation of x square, expectation of y square. That's why we construct the table first. What is the requirement for these values? First we construct the table. Here the values, here is x and now y, and then we require of x square, require x, y square is also required, and then we write for the xy. Now x values is given 1 2 3 4 5 6. Now y is also given 6 4 3 5 4 2, and now x is 1 4 9 16 25 36 Here is 36, 16, 9, 25. Here the y square, that's why we can write here. Here is 16, here is 2 square 4, and need for the xy, then we multiply this both column. It is coming 6, 8, 9, 20, 20 and 12. And after that we find the values of summation of x. Summation of x is after adding this column, which is getting 21. Here is provide the summation of y is coming forward 24. Here is summation of x square is coming 91. Here is coming summation of y square is after adding this column 106, and it's provide the summation xy is coming what 75. Now need to find why are we going to find the summation x square summation f xy. Here we targeted to find the expectation of x. Now we can use this formula 1 by n summation of x. Means that we what is the n values according to the question. Here is n is what? N is given 1 to 6. Here n is given according to the question, n is given 6, that's why I write 6, and here is 21, and after calculating its values are coming 3.5. Now similarly we need for the x square, how to find 1 by n summation x square. The summation x square is 91 by 6. 91 by 6 is what? 15.16 is coming. And similarly we find the expectation y as 1 by n summation y. Summation y is given here 24. 24 by 6. 24 by 6 is coming 4. And now expectation of y square is coming 1 by n into summation of y square. Here we write summation of y square is equal to 1 by 6 divided by 6 is coming what? 17.1 17.66. Now then we required for what? Expectation of xy. Expectation of xy is 1 by n summation xy. Here we write 1 by 6 into summation of xy is 75, and we get 12.5. That 12.5. Now after that we required for the covariance term in equation number 2. From the covariance term is what? Xy. Xy is equal to expectation of xy minus expectation of x into expectation of y. Here substituting expectation of x is 12.5 minus expectation of x is 3.5 into expectation of y is given 4, and now after that we calculate it is coming for minus 1.5. And now the need for the summation of x square. Here we write for the x square need for what? Expectation of x square minus expectation of x whole square. That's why we can write summation of x square is 15.16 minus expectation of x is what? 3.5 whole square. And now we get this result is what? Result is coming under root of 2.91, and after that we find the square root is coming 1.7058. 1.7058. Now similarly we find the sigma y. Sigma y we write for the expectation of y square minus expectation of y whole square. We write here expectation of y square is 17.66 minus expectation of y is 4 square. Then after that we calculate it is coming 1.66. Then we find the square root of this, it is coming 1.2884. Now from the equation 1, from 1 we find the correlations between x and y is equal to covariance of xy divided by sigma x into sigma y. Then we write here minus 1.5 by 1.7058 into 1.2884 means that after calculating this value we get the value is 60.682 means that. So what is the description of this correlations coefficient? Here the row is lies between, just we go for in upper part, what is the description? Here the description is what? The correlation coefficient is lies between this part is minus 0.6 and this is a strongly moderate values is given. Now this is the answer for this question. Now the answer for the first question. This is the answer for the first question. Now move for the example number 2. Next is example number 2. Now example number 2. Here is coming two variables. Suppose two random variables x and y are defined as y is equal to 2x plus 7. Find find the correlation find the correlation coefficient between x and y. Find the correlation coefficient between x and y. Now first we write the formula. Solution, we know that the from equation 1, from 1 we know that the from 1, here the from 1 row xy is equal to covariance of xy by sigma x into sigma y. Now targeted to find the covariance of xy. Covariance of xy is what? Expectation of xy minus expectation of x into expectation of y. Now here targeted to find the sigma x. Here expectation of x, and we know that y is given. Here is y is given 2x plus 7. And now here is need for the expectation of x. We write the expectation of x and substitute the values of y is equal to 2x plus 7. 2x plus 7. So here we write the expectation of 2x square plus 7x minus expectation of x into, here we write twice of expectation of x. When we take the expectation of 7, it is coming from what? Only for 7. Now after that we twice expectation, taking expectation in inside, the twice into expectation of x square plus 7 into expectation of x, and here we write twice of expectation of x square minus 7 into expectation of x. Now these values are cancelled out, plus minus is given, and after that we write here 2, and we write in expectation of x square minus expectation of x whole square. This is for what? We know that this is for what? This is the variance of what? Twice of sigma x square. This is the variance of twice of sigma x square. This is the answer for the covariance. And now our target to find the next is sigma square y. Therefore, the sigma square y is what? We know that this is the variance expectation of y square minus expectation of y whole square. Here we write expectation of y is what? Y is given. Here is expectation of y is given 2x plus 7 whole square minus here the expectation of 2x plus 7 whole square. Then here we write the expectation of, just we write for the a plus b square. Here is 4x square plus 49 plus 28x minus, here we write for the twice of expectation of x plus 7 whole square. Now we write 4 into expectation of x square plus 49 plus 28 into expectation of x, and here we write minus 4 expectation of x ka whole square minus 49 minus 28 expectation of x. So here we cancel out, 49 is cancel out, 49 plus minus 28 into expectation of x is already cancel out, and here we have seen that these values are coming, v4 is coming outside. Now it coming expectation of x square minus expectation of x ka whole square, that is for what? Here is coming 4 into sigma x square, means that we write the sigma y is equal to twice of sigma x. This is the result is coming. So now we know that the formula for the correlations coefficient, therefore rho xy is equal to covariance of xy into sigma x into sigma y. Here we write, here we sigma covariance of x is coming to sigma x square, and now sigma x into twice of sigma, substituting the value of sigma y square here, y square, here is coming x, and after that it gives the sigma xy is equal to 1, means that it is the positive, perfect positive correlations. It's provide the perfect positive correlations. So now we move for the next question. The next question is the joint probability mass function of x and y is given below. X and y is given below. Given below is given, here is x and here is y. Y represent y contains, y random variable contains the sample value 0 or 1, x contains minus 1 and 1, and particular probabilities is given 1 by 8, 2 by 8, 3 by 8, 2 by 8, and now here find the correlation, find the correlation, find the correlation coefficient, find the correlations coefficients. So now go for the solution first. In this section, first we write for the, we find the marginal, find the marginal probability mass function, probability mass function of x and y. Probability mass function of x and y. Just we construct the table first. Where we construct this. Here is x, here is y, here is 0, 1, and this is for minus 1 and 1. Now here is corresponding of x, that's why we write the marginal probability mass function of x, and here we write the corresponding of y values, that's with the marginal probabilities mass function of y. Now its particular values is given 1 by 8, 2 by 8, 3 by 8, 2 by 8, and from the table need to find the probability of x minus 1. Probability of x minus 1. Probabilities of x minus 1 is what? Here is just we go for the 1 plus 8. 1 plus 8 plus 2 by 8 is equal to 3 by 8. Here we write for the 3 by 8, and we write for the next probability marginal probability mass function of 1. This is coming from what? Now in this section 3 by 2, 3 by 8 plus 2 by 8 is equal to 5 by 8 here. So just we write here 5 by 8, and similarly we find y of 0 is equal to 1 by 8 plus 3 by 8 is coming 4 by 8. We write here 1 by 2, and similarly we find the probability marginal probability mass function of 1. It is coming from what? 2 by 8 plus 2 by 8 is equal to 4 by 8 is equal to 1 by 2. Here is also coming 1 by 2. Then we write 1 by 2. Now our target to find this values. This is the table of this. And now need for the find. First we need for the expectation of x. And how to find the expectation of x in probability joint probabilities mass function is given. Here we write the summation of x I. This is x is represent the I, and j is y is represent the j values. And here we take the xi, I is what? Minus 1 and 1. And here we write the probability, marginal probabilities mass function of x. Now we write how to find these values. Here the minus 1 into p of x is given. P of x is what? P of x is what? This is 3. Here the value is given 3 by 8 plus x values are next is 1 into what? Here the probability marginal probability mass function of x is given 5 by 8, and after calculating we get the values of 2 by 8 is equal to 1 by 4. Now similarly we find the expectation of x square. Here we write the summation I xi square p of x into xi. This is the marginal probability mass function of x. Here we write for the minus 1 square into 3 by 8 plus 1 square into 5 by 8. It is coming from 8 by 8 is equal to 1. Now we go for the similarly expectation of y. expectation of y is equal to what? Summation of y, summation of j and yj into marginal probabilities of y. Here we write of yj. And now similarly we write 0 into what? 1 by 2 plus 1 into 1 into 1 by 2. It is coming what? 1 by 2. It is coming what? 1 by 2. Now here similarly we write expectation of y square. We write the formula summation of j yj square and marginal probabilities of yj is equal to 0 square into 1 by 2 plus 1 square into 1 by 2. It is always coming, it is again becoming 1 by 2. Now we need to find the expectation of xy, expectation of xy. Now in this case write the formula summation ij, and here we write xi yj into joint probability mass function. Here is joint probability mass function is given y of xi yj. In according to joint probabilities mass function is given, here we find the joint probabilities mass function, means that we write here, how will we write? Just we go for minus 1 0 into 1 by 8 minus 1 into 1 into 2 by 8, and now we are writing here we writing for the minus 1 into 0 into 1 by 8 1 by 8 plus minus 1 into 1 into 2 by 8 plus my 1 1 into 0 into 3 by 8 plus 1 into 1 into 2 by 8, and here is coming what? 0 minus 1 by 4 plus 0 plus 1 by 4 is coming values. The expectation of xy is equal to 0. Now our targeted to find the values of covariance. Now covariance xy, it is known that expectation of xy minus expectation of x into expectation of y. Here the expectation of xy is 0 minus expectation of x is coming 1 by 4 and expectation of y is coming 1 by 2. It is coming from minus 1 by 8. And now therefore we write the, from equation 1 we write the correlation coefficient rho xy is equal to what? Covariance of xy into sigma x into sigma y is equal to minus 1 by 8 by, here is sigma y is what? Sigma y values, just we check what is the value sigma y is coming. Sigma y, so here we have not find the sigma y, so just we required to find the values of sigma x and sigma y here. Just we need to find the sigma x square. Sigma x square is equal to what? Under root of expectation of x square minus expectation of x whole square. Here we write for what? This is the summation x square is coming from 1 minus expectation of x square is 1 by 4 whole square is coming 1 by 16. Means that we result is coming under root 15 by 4. And similarly we find sigma y. Here I am directly writing expectation of y square. Expectation of y square is what? 1 by 2. Here is 1 by 2 minus expectation of y square. This is for the 1 by 2 whole square means 1 by 4. It is coming from what? It is coming under root of 1 by 4 means that it's give 1 by 2. And now here substituting the values in the final formulas, correlation coefficient. Here we put the 15 by 4 into 1 by 2, then it gives minus 0.2558. This is the result for this question. So these questions are based on the joint probabilities mass function. So now we move for the next question. Here the next example, last example, example number 4. Let x and y be the random variables having joint PDF probability densities function f of xy x comma y is equal to is given 3 by 2 bracketed x square plus y square, and x lies between 0 and 1, y is also lies between 0 and 1, and herefore write 0 otherwise. Now find the correlations coefficient rho xy. Now in this case we know that in a similar way we know the formula for the variance for this. First we write the formula correlations of xy is equal to correlations coefficient of xy is equal to covariance of xy into expectation of x into expectation of y. So first need to write the covariance of xy. Covariance of xy is what? Expectation of xy minus expectation of x into expectation of y. Now our target to find the first is expectation of xy. Here we write the expectation of xy, but here is joint probability densities function, continuous function is given. Then how to write the expectation of xy? So just we write here the formula is minus infinity to plus infinity, minus infinity to plus infinity, xy, and here we write the joint probability mass function, probability densities function. So probability densities function xy xy dx dy. Now we write, and according to the question here is 0 1 0 1 xy, and now the joint probabilities density function is given 3 by 2 x square plus y square dx dy dx dy, and here is the limit is constant, no use the change of order. So here we go for the x parts 0 to 1, and here we write for just a constant part we write for the outside here 3 by 2, here is 0 and 1, and then we write here y, and x is what? X cube plus x y square dx dy. Now our target to first integrate with respect to x. So here we write 3 by 2 0 to 1. Now after integration here is coming what? X4 by 4 plus x square by 2 y square, and now x is equal to 0 to 1, and here we write dy, and now with 3 by 2 bracket 0 to 1, and here y is already is given y, here is y, and after that we coming from 1 by 4 plus y square by 2 dy, and then we write 3 by 2 3 by 2 0 1 y by 4 plus y cube by 2 dy, and then we integrate here with respect to y 3 by 2 3 by 2 integration is coming what? Y square by 8 plus y to the power 4 by 8, meaning y is equal to 0 1. Then after that we coming 3 by 2 1 by 8 plus 1 by 8 is equal to 3 by 8. Here is 2 by 8 into 2 to cancel, 3 by 8 is coming. Now this is portion for the expectation of x, y, and now we find the expectation of x. Before going to expectation of x, need to find the marginal. Here we find the marginal PDF of x is given by marginal PDF of x is given by, here is marginal PDF probability density function of x. Is formula is minus infinity to plus infinity. Right here joint probability distribution of a joint probability density function of xy dy. Now according to the question, the limit is bounded 0 to 1, y values is given to 1. Here we write the joint densities function 3 by 2 x square y square dy, and now we simplify here, and here simplify we get the result of 3x square plus 1 by 2. So I'm not going to evaluate this, so I'm directly we write the values. So this is for 3xy, and similarly we write f of y of x is equal to, here we write the formula clearly, minus infinity to plus infinity fxy xy dx, and here we limit is given x in according to the question, x lies between 0 to 1, or here is 3 by 2 x square plus y square dx, and after calculating we get the values is 1 plus 3y square by 2. Now our target to find the expectation of x. Now in this joint probability density function, how to find the expectation of x? Here the requirement of minus infinity to infinity x into f of x dx. This is known as the marginal marginal probability density function of x. That's why we find before this. And after we substitute these values 0 to 1, x values x into, here we write 3x square plus 1 by 2 dx. After calculation we get the result is 5 by 8. I am not calculating this, so you calculate. And here we write for the expectation of y. This is similarly we write the expectation of y minus infinity to plus infinity y marginal probability density function of y dy is equal to 0 to 1 y into 1 plus 3 y square by 2. So this is very simple integration. So just we go and simplify. This is answer is coming 5 by 8. Now the covariance term xy is coming what? Expectation of xy minus expectation of x into expectation of y. Here the expectation of x is what? 3 by 8 minus expectation of x is 5 by 8, and expectation of y is 5 by 8 also is coming. Now after calculation we get the result is 24 minus 25 by 64. This is the answer is coming minus 1 by 64. This is the answer for the covariance of xy. Now our target to find the sigma x and sigma y square. That's why we need to find here. Again, this is the result for the covariance term. And next for the expectation of x square. In a similarly, we write minus infinity to plus infinity x square. Here we write the marginal density function of x dx. Here limit is given x 0 1 x square. Here we write 3x square plus 1 by 2 dx, and after calculation of this integral we get the result is 7 by 15. So now similarly we write the expectation of y square. Here we minus infinity plus infinity y square and marginal probability densities function of y dy, and this is the limit is y is also given 0 and 1 y square, and here we write for the 3y square plus 1 by 2 1 by 2 dy, and after calculate this integral, the answer is coming, always it is coming 7 by, it is now incoming same result for the expectation of x square and expectation of y square. Now our target to find the expectation of x, this is what here we write for the expectation of x square minus expectation of x ka whole square. Let's we use the formula first. Here is given 7 by 15 minus 5 by 8 whole square. So after simplify we get the result, it's 73 by 960. And now similarly we find sigma y square. This is also coming 73 by 960. So both are equal. Now we need to find the correlations coefficient xy. This is the covariance of xy is equal to sigma x sigma y is equal to given minus 1 by 64, and these both values are equal. That's why we write here these values are coming 0.2757. Here we write 0.2757 whole square, and after calculate these values are coming minus 0.20547. So thanks for watching my video. So please like, comments and subscribe my channel.